Hello everyone. Today let's solve the problem number 25 here. Reverse nodes in K group. So we have been this one. You can just go through the question first and you can just try to understand the same thing with the help of example. So I'll just summarize the question so that it will be easier to understand. So we are given a linked list and an integer K here. So we are given a linked list and integer K here. You can clearly see our main task is to reverse the nodes of the list in the groups of K. Reverse the nodes of the list in the groups of K they have given. This is important, right? If the number of nodes left at the end is less than K, then we leave them as it is. So that's what they have given here. So example they have showed here 1, 2, 3, 4, 5. K they have given 2 here. Let's consider in groups of 2 elements. So first thing we are reversing this one. 2, 1. So here we got 2, 1. Next two elements we are considering this one 3, 4. So it will be 4 and 3. 2, 1, 4, 3 we have. Fifth element we have 1. K they have given 2. If the element is less than K, we have only one element. Now the K is 1, right? If 1 is obviously less than 2 here. So we are leaving the 5 as it is. The output will be 2, 1, 4, 3, 5. That's what the question states here. Let's move with the second question. Similar to the first one. Here K they have given 3. So we are considering 3 elements at a time. So 1, 2, 3 will be 3, 2, 1 when reversed. So it will be 3, 2, 1. Finally, this one is these two elements are 2 elements we have. 2 elements is left which is less than 3 quite obviously. So we are leaving as it is, this one 4 and 5. So I hope the question is completely clear. So let's discuss the approach and then try run the first example that they have given here, this one accordingly with the approach, and then finally write the edge cases and finally write the code and discuss the complexities of the code that we have written. Initially, as usual, we'll be moving with the approach. So here we are going with the iteration. So the approach that we are going with here is iteration, simple iteration. So first step is what we'll do here. Let's create the we'll be creating the dummy node. So initially what we'll be doing, we'll be creating the dummy node that points to the head here. This will be the first step. Why we are doing this one? Basically this helps us handle the edge cases easily. That is the reason in most of the cases we'll be creating the dummy node that points to the head. Then we will be traversing the list in groups of K, right? So that's what the question states here. So we have to reverse the elements accordingly with the K, right? So we are traversing the list in the groups of K. We are here traversing the list in the groups of K here. This is fine. For each group, reverse the K nodes. For each group, we are reversing the K nodes. So I'll just give here a reverse. For each group, we have to reverse the K node, right? So then connect the reversed group back to the rest of the list. So then again connect the reversed group back, right, to the rest of the list. So that is what we'll be doing here in the second step. So let's move on with the third step. Nothing but we have to stop when fewer than K nodes remain. This we have seen this one in the example, right? Suppose if we have here 1, 2, 3, 4, 5 and K is 2 they have given, we'll be reversing this one. This will be 2, 1 and this will be basically just give me a second here. What happened to this one? This 3 and 4. This will be 4, 3 and finally while I say stop when fewer than K nodes remain, here we have K equals 2 and this one only one element left. So 1 is less than 2. Here we stop this one as it is. We'll be giving this one. This one will be 2, 1, 4, 3, 5, right? So we will stop when fewer than k nodes remain. Finally, we will return the modified list starting from the dummy nodes dot next. This is important. We will return the modified list starting from dummy nodes dot next. Dummy nodes dot next. Just keep this in mind. Sorry, dot next. This one. We are returning the modified list starting from the dummy nodes dot next. So I hope the approach is completely clear. Now let's discuss the edge cases one. So let's discuss the edge cases one by one. First edge case is when k equals 1. When k equals 1, let's consider here input head. Let me consider here 1, 2, 3, and also let me consider here k equals 1, right? So we have to, when k equals 1 itself, we are considering, right? So the output will be here 1, 2, 3 itself. So no changes here because we are reversing one element. So no changes as reversing one element results in the same list, right? That we know here. This is for the condition when k is 1. So next, when k is n or when k equals to n, nothing but the size of the list. So here let me consider input. Let me consider something 1, 2, 3, 4, and let me consider k equals 4 as well. So here output will be 4, 3, 2 and 1, right? So the entire list is reversed here because they have given k equals 4. We are considering this for these all elements at a time. All the elements at a time, and we are reversing all the things, all the elements. So the output will be 4, 3, 2, 1 here. This is for the condition when k equals n. Let's move on with the third edge case. Nothing but list size not divisible by k here. When list size is not divisible by k here. When I say this one, let's consider the input. You will understand this one clearly. So here this will be 1, 2, 3, 4, 5. Let me consider head here. And the k, let me consider here 3. This is fine. And output we will be consider here. We'll be considering here 3, 2, 1, 4, 5. So when I said list not divisible by k, last two nodes remain as it is. So that's what I meant here. List size not divisible by k. So this is one thing. And the final edge case or the fourth edge case, let's go with a single node list here. When I say single node list, let's consider the input here head equals 1 and k also let's consider here k equals k 1. Sorry, just give me a second here. K equals 1 here. This is fine, and the output will be 1 here, right? So we have only one element. So when we reverse, k is also 1. When we reverse, we get the output 1. So these are the 4 edge cases that we need to remember. When k equals 1, when k is n, and when list size is not divisible by k, we saw this one here. And finally, for the single node list. So now we have discussed all the edge cases. Let's start writing the code. I'll just explain the code while writing the code itself. So first what we'll be doing here, as we had discussed in the approach, let's create a dummy node to handle the edge cases easily. So I'll just give here let dummy equals new list node of 0, the first node, right? So I'll just give 0 here. So I'll just give here let p equals dummy. And finally, we have to connect the dummy to the head of the list, right? For connecting the dummy to the head of the list, I'll just give here dummy.next equals head here. This is fine. So let's go with while of p here. So within the while loop, what we'll do here, we'll check if there are at least k nodes ahead. So first in this we have to check, right? So we are just checking if there are at least k nodes ahead. So I'll just give here let t equals p, and then let's go with the iteration for let I equals 0, I less than k, and also we have to consider t here, and finally let's increment the I, and t equals t dot next. This is fine. And the final one is, if it is less than k nodes, if less than k nodes remain, then we will exit the loop. I can just give here, if not of k, then let's break. So I'll just give here break. This is fine. Let's move on with the third step. Reverse the next k nodes. While I say reverse the next k nodes, we have to, after reversing the first this one, suppose if we are having 5 elements and k equals 2, so then we have to move to the next one, right? So we have to reverse the next k nodes as well. For that, I'll just give here let previous, and let's consider the current element. Here, let's go with the reverse. Just give me a second here. Did I miss anything? Let's go with p dot next. Okay. So after this step, the original first node of the group becomes the tail, right? So I'll just give here tail equals p dot next. So now let's connect the tail to the rest of the list. So to connect the tail to the rest of the list, I'll just consider tail dot next, and let's initialize this one to the current. After doing this, let's connect the previous group to the linked list as well. So we have to start connecting one group with the another, right? After reversing. So for that, I'll just give here p dot next. So let's initialize this one to the previous. Finally, we have to move to the next group. For that one, let me initialize p to tail here. So this is fine, I think. So final step, sorry, not the final step. So this one here, we have to return the modified list, right? So here I'll just give dummy dot next. I hope this is clear. So here I have written reverse, right? We are making use of the recursive function. So this I shouldn't have. I have not written the function reverse at all. So this I should have written first itself. This is fine. I'll just give here reverse head, k. So we are just making use of the recursive function reverse here. So let's see. Let's write the this one reverse function. So first let's initialize the pointers for reversing. I'll just take 2 pointers here. One is previous and one is current. Let's initialize the previous to null. We have already solved the problem, reverse the linked list, right? So this is similar to the same thing. So here we are writing the reverse function, and we are just making use of the here recursive function. For p dot next and k we are calling, right? So here this one. So I'll just give here pref equals null and current. Let me initialize this one to the head. This is fine. Step 2, let's move on to the next step, or you can call this one as step 2. Let's reverse k nodes. We have to iterate through each node, right? So I'll just give here let I equals 0, I less than k, and finally let's increment this one. We have to store the next node. For storing the next node, I'll just consider the variable next and initialize this one to current dot next, and reverse the current node now. Let's reverse the current node now. So we have the current dot next. We have to reverse the current node. So let's initialize this one to previous, and after this step, we have to move the previous to the current node, and we have to move the current to the next node. So I'll just give here previous, current, and finally current. We have to move the current to the next node. I hope this is clear. The final step in the reverse function is we have to return the new head and the next node. Let's return new head and the next node, right? Nothing but previous and current here. I hope this is clear. So let me format the code once and let me hit the run button. So cannot read properties of null here in line number 25. current dot next. So what is the problem? Here, what mistake I have done here is in the line number 6, you can clearly see we are just checking within the while loop. We are just checking initially if there are at least k nodes ahead, right? So we are initializing t to p. So here, if not of k, so what we are doing here, we have to check if there are less than k nodes remaining. So if if less than k nodes remain, then we have to exit the loop, right? Here it has to be t, not k here. So this mistake I have done. I'll just format the code once and let me run the code again here. So now we can clearly see that sample test cases are getting passed here. So let me hit the submit button now. So now this works absolutely correct. So all the test cases are getting passed here. So the code works absolutely correct here. Let's quickly discuss the time complexity and the space complexity of the code that we have written here. The approach that we went with here is iterative reversal. We know that one. And what will be the overall time complexity here? The overall time complexity would be big O of n. Why the overall time complexity would be big O of n here? Each node is processed exactly once here. We know that each node is processed exactly once, and reversing takes big of k per group, right? So overall time complexity would be here big O of n, as each node is processed exactly once. And what will be the space complexity here? The overall space complexity would be big of 1, because we are not making use of any extra space except for the pointers here. You can clearly see, except for the pointers, we are not making use of any extra space. So the overall space complexity would be big O of 1. Overall time complexity would be big O of n, and overall space complexity would be big O of 1. I hope the solution is completely clear, right? For now, this is it. Thanks for watching, guys.